Hello everyone, today's video is about solving quadratic equations by using the extracting square roots. And before I give you the 5 examples, let me just remind you about these 3 things. But of course, the first one is we use this method if the quadratic equation is in the form of x squared minus k equals 0. So meaning the leading term, x squared, and the constant number are the two terms that are normally given when we use extracting the square roots. And I'll just remind you of these 3 possibilities when it comes to the answers or the roots or the solutions. And the first one is if k is greater than 0, then we have here, or the equation is going to have two real solutions or roots. And the answers are that positive square root of k and negative square root of k. The second possibility is if your k is equal to 0, there will be one real solution and the root or the value of x is equal to 0. And then finally, if your k is negative, then there will be no real solutions or roots, meaning the answers or the roots are imaginary. All right, let me give you now 3 examples. So one for each of these 3, and I will give you 2 more after that. Okay, so these are the 3 possible examples. So how do we solve quadratic equations using extracting the square root? The whole idea here is to separate the leading term, which is x squared, and the constant number. So for the first one on the left side, that x squared minus 40 equals 9, what I will do here is I will add 40 on both sides, cancel that. It will give us x squared equals 49. And based from the first statement that you saw earlier, to find the roots here, all we need to do is to find the square root of 49. And as you can see earlier, there are 2 possible answers here. Positive, negative. The square root of 49 is 7. Alrighty? And then the second possibility is this one. So subtract 8 on both sides. X squared equals, that's also 0. And the square root of 0 is just equal to 0. Alright? And then the third possibility is this. You subtract 12 on both sides, right? So x squared equals negative 5. And if you use your calculator, right here, the answer will be imaginary or error. Use your calculator, you will see an error if your calculator is not, it's a regular calculator. So positive negative square root of negative 5 is the answer. So no real roots here. Okay, let me give you 2 more examples. Okay, so here, this is not in the form of x squared minus k equals 0, but we will solve this one using the method of extracting the square root. So on the left side, x plus 4 squared minus 2 equals 4. The first thing we will do here is add 2 on both sides. That will give us x plus 4 squared equals 9. And in extracting the square root, we will find the square root of both sides of the equation. So this will be x plus 4 equals positive negative square root of 9 is 3. Now, so since we have positive 3 and negative 3, we will be having 2 possible solutions here. The first one is x plus 4 equals 3, and then the second one is x plus 4 equals negative 3. So to solve this, subtract 4, this will be negative 1. And then the second one is subtract 4 on both sides, that will be negative 7. Alright, let's answer the last example here. So subtract 3 on both sides, that'll give us 3x plus 8 squared equals 16. And square root of 16 is positive negative 4. Cancel out the exponent 2, and this will give us 3x plus 8. And then we will separate that into 2 possible solutions or answers. The first is 3x plus 8 equals positive 4, and then the next one is 3x plus 8 equals negative 4. So subtract 8 on both sides. This will be 3x equals negative 4. Then divided by 3, x equals negative 4 over 3. Alright, this one, negative 8, negative 8. So 3x equals negative 12. They have the same signs. Divided by 3. So x equals negative 4. That's a little bit fast because this is an easy topic. So that's how you solve quadratic equations using the extracting the square root. Alright, thank you for watching. I hope you learned something, and please do not forget to like and subscribe to my YouTube channel. Thank you and have a nice day. Bye-bye.